Half past paper, week 13, and we're back to non-calculator this week. All the odd numbers as usual, and all the Sparks codes if you do have access to Sparks, or if you just want to know what the topics are that we're going to go through in this paper, they are here for you on the front. Okay, question number 1. Write the following numbers in order of size. Start with the smallest number. So with decimals, write them over the top of each other and make them all the same length. So 0.309, and then make them all the same length. So use zeros to fill in the place value. Now we are comparing the tenths column first. All the ones columns have 0, so there's nothing in that column. So let's move over to the tenths, and I've got 3, 4, 3 and 3. So we know that the smaller ones are going to be out of the ones with the 3s, but that doesn't really help us because we've got 3 of them that have a 3 in that column. Moving over again, I've got 2 of them with zeros, but one of those is with the 4. So here we go. This one is going to be our smallest, 0.309, and that's going at the beginning. It says start with the smallest. Then it's going to be 0.320, or just 0.32, and then it's going to be 0.35, and then it's going to be 0.4 as the biggest because it has 4 tenths, which is bigger than any of the numbers with 3 tenths. Okay, question number 3, write 4.666 correct to the nearest whole number. So to the nearest whole number, we know it's between 4 and 5, but 4.666, that's going to be closer to 5. That next number in the tenths column is 5 or above. It's a 6, so it rounds up. So 5 to the nearest whole number. Question number 5, write down the value of the 7 in the number 8,765. So the mistake a lot of students make here is writing hundreds. Yes, it is in the hundreds column, but what is the value of that 7? It's worth 700. So you either need to write 700 like this. You can write 700s. That's absolutely fine. That's what it's worth. But the 7 is worth 700. You can't just say hundreds and just say what column it's in. That's not okay. Okay, question number 7. The incomplete pictogram shows information about the number of eggs sold from a farm shop on Monday. On Monday, the shop sold 18 eggs. So we're told that this is 18. On Tuesday, 24. So we'll just pop that there. And on Wednesday, 27. Use this information to complete the pictogram and the key. So we now know that this needs to be 18. And I've got 6 little sections here. 6 equal size sections. 1, 2, 3, 4, 5, 6. So I'm going to take that 18 and divide it by 6, and that tells me that each of these little sections is worth 3. 18 divided by 6 is 3. So 3, 3, 3, 3, 3, and 3. There we go. So the key, I'm now just going to do a full circle, and let's cross it just so that it's the same as those, is going to equal 12 eggs. So it's 3, 3, 3, and 3 to make a full circle. Now for Tuesday, we've got to do 24. So I know that one full circle is going to get me 12, and I'll need another full circle to get another 12, because 12 add 12 is 24. Same thing for Wednesday, I've got to go to 27, so let's do one full circle, another full circle, and that gets us 24. I need to get 27, so that's an extra 3, so I need one more little section like that. We've completed the pictogram, we've completed the key, so that's all done for 4 marks. Question number 9. A bag contains red counters and blue counters only. The number of red counters to the number of blue counters is in the ratio 3 to 4. Write down the fraction of counters that are red. Okay, so I find it helpful with ratio just to visualise it. You can either do little boxes or little lines like this. The number of red counters to the number of blue counters is in the ratio 3 to 4. Write down the fraction of counters that are red. So this side is red, and this side is blue. The fraction of counters that are red are going to be 3 sections out of, now a really common mistake is people put out of 4. It's not out of 4. If you look at the total, how many lines have we got all together? It's out of 7. So fraction that is red is 3 out of 7. For part B, write the ratio 12 to 30 in the form 1 to n. So with ratios, a little bit like fractions, whatever you do to one part you need to do to the other to keep them equivalent. If we want it to be 1 to something, and that n means it can be anything you like, but we need to make sure we do the same to both sides. So I've divided the left-hand side by 12. I've also got to divide the right-hand side by 12, and you're thinking, hang on, 12 doesn't go into 30, so let's use a fraction and we can just keep simplifying it. 30 divided by 12 is the same as 15 divided by 6. I've halved the top and halved the bottom. And they're both in the 3 times table, so that's the same as 5 over 2, and that's a little bit easier. 5 divided by 2 is 2.5. All of those fractions are the same thing, so I now know that 30 divided by 12 is 2.5. So there we go, that goes there, and the ratio they're looking for is 1 to 2.5. 12 goes into 30 2.5 times. Question number 11. Reflect the shaded shape in the mirror line. So when we do reflections, we need to think about how far away this shape is from the mirror line and make sure it stays the same distance away on the other side. So at the minute, that top point is 4 squares away, so we need to stay 4 squares away on the other side. Here, this is 2 squares away, so we need to make sure it goes there. This point is 3 squares away, so it's going to go there. This point is 3 away, it's going to go there. This point is 4 away, and so on. And then you can join it up with a straight line with a ruler, or you can just freehand it if you're very careful. Probably don't follow my lead on that, use a ruler. There we go. So that's the same distance away on both sides reflected in that mirror line. Question number 13. The diagram shows 2 points A and B on a map. The scale is 1 to 25,000. So that means 1 centimetre on my map is 25,000 centimetres in real life. Or 1 metre on my map, which is probably we're not going to use that because the map probably wouldn't be that big, would be 25,000 metres in real life. So the units are consistent there. 1 to 25,000 means that real life is 25,000 times bigger. Find the bearing of B from A. Now, bearings are angles. So what you're going to do is get your protractor. The first thing you need to do is draw a line going from A to B, because we want to measure an angle, so we need to have a line to measure against. And the bearing of B from A means you are stood at A, and you're going to get your protractor and pop it over the top. So I can't quite show you how to do that on my iPad, but hopefully you can work with me here. You'd have a protractor like this, all the numbers going around the outside, and you want to put 0 so that it's north, so that it's facing the top. And then you're going to measure round until you get to that line there. Okay, that is bearings. Bearings need to start north and go clockwise. So the error that most students make is they put their protractor that way. Okay, but you want to make sure the 0 is at the top and then you're reading round. Now you were allowed any bearing there from 23 to 27. So that was the range of tolerance. Now with bearings, we always need to make them 3 digits long. So I would measure that as 25 degrees. And so I'm going to put 0 to 5 as my bearing. We always need to make sure it's got 3 digits. So if you do get a bearing that's less than 100, make sure you just put a 0 in front. They did allow it if you didn't put that 0, but they don't always. So make sure you do that just to be on the safe side if it is a bearing. Then it says the real distance between A and B. Work out the real distance, between A and B. Give your answer in kilometres. So if we measure this blue line that I've drawn here, if we measure how long that is with a ruler, you should get a measurement between 4.8 and 5.2. I'm going to go with 5 centimetres. So for me, when I measure this, it's 5 centimetres long, but you were allowed anything from 4.8 up to 5.2 centimetres. Okay, that was the range that was allowed. I measured it as 5 centimetres. Now, if that is 5 centimetres long on my map, then in real life, we know it's 25,000 times bigger. So I'm going to do 25,000 times by 5, and that is 0, 0, 0. 5 times 5 is 25, so 5 carry the 2, and 5 times 2 is 10, add the 2 is 12. So in real life, it would be 125,000 centimetres. But I don't want my answer in centimetres, I want it in kilometres. So the first thing I'm going to do is get it into metres. 125,000 centimetres, 100 centimetres is a metre. So if we divide by 100, that's going to be 1,250 meters. I've divided by 100 to get it into meters. And then I know that every 1,000 meters is a kilometre, so 1.25, just dividing by 1,000, 1.25 kilometres would be your answer. But again, you'd be allowed anything from 1.2 up to 1.3 because of reading within the different tolerance that was allowed there. Question number 15. Jamil makes a drink by mixing 1 part orange squash with 9 parts water. He uses 750 millilitres of orange squash. Jamil is going to put the drink he has mixed into 1 litre bottles. Work out the greatest number of 1 litre bottles that Jamil can completely fill. So again, this is a ratio question. We're putting 1 part orange squash to 9 parts water. Now, if he uses 750 ml of orange squash, we need to do 750 on each of these lines as well. Now in total, that needs to be 9 lots of 750 for how much water there would be, and 1 lot of 750, which is your squash. So you could do 9 lots of 750 and add it on, but the easiest thing to do here is know that in total, with the orange squash and the water, I'm doing 10 lots of 750. And 750 times by 10 is 7,500 millilitres. So that's how much he's going to have. Now we're putting that in 1 litre bottles, and every 1,000 millilitres is 1 litre. So therefore, if I divide that into thousands, it's going to be 7.5. But that's not what I want to get here. It says how many litre bottles can he completely fill. So I don't want to put the 0.5 on the answer line. I want to say 7 is how many he can completely fill up. And the extra bit left over, we just wouldn't talk about that. We wouldn't include that in our answer. So 7.5, that's going to get us 2 marks out of 3. But for that third mark, you do need to say 7 on the answer line. Question number 17. In a shop, a TV has a normal price of 500. The shop has a sale. On Monday, the normal price of a TV is reduced by 1/10 to give the sale price. So let's work out 1/10 of 500. And when we do a fraction of an amount, we divide that number by the bottom and then times it by the top. So 500 divided by 10 is 50. 50 times 1 is still just 50. So we're going to get £50 off. So on Monday, 500, take off the £50 discount, it's now £450, and that's going to be the sale price after that reduction on Monday. On Tuesday, the sale price, so they're taking this price here, 450, and reducing it by 20%. Now to find 10% of 450, we would divide by 10. If you want 10% of a number, you divide by 10, because 10 lots of 10% makes 100%, makes the whole number. So 10% of 450 is £45, which makes 20% double that. So 20% would be 45 and another 45, so £90. And so we're going to reduce it by that as well. 450, take off the £90, more on the floor, borrow from next door. So the 0 take 0 was okay, 5 take 9 I can't do, I'm going to borrow 1 from here, 15 take 9 is 6, and 3 take 0 is just 3, so £360. Chris wants to buy the TV. He's got £400 to buy the TV. Does he have enough money? So, yes, he has enough. Always answer the question, remember. The TV costs £360, which is less than 400. I think my handwriting's getting worse each week. There we go, which is less than 400. Perfect. Question number 19. Expand x minus 4. Okay, when we expand brackets, we're saying I want this many lots of everything in the bracket. So we do what's on the outside multiplied by the first thing and what's on the outside multiplied by the second thing. And you can put little multiplication signs there if you find it easier. X times x is x squared, you're multiplying it by itself, and x times minus 4 is minus 4x. Those are not like terms, so that is your final answer. You can't bring them together to a single term. That is your answer. Factorise is the opposite of expanding. So with expanding, we're taking it out of the brackets by multiplying. Factorising, we are looking for a common factor to go outside of a bracket. So factorise means put it into brackets, and we're looking for a common factor. 15y and 10 can both be divided by 5. So I'm going to put 5 outside the bracket. What would I need to multiply that 5 by to get 15y? Well, I would need to multiply it by 3, and also I would need to multiply it by a y. So 5 times 3y would give me the 15y that I'm looking for. And then 5 times what is going to give me minus 10. I would need this to be minus 2. Remember, you're multiplying, so working backwards, it's going to need to be minus 2. And that's our answer, 5 lots of 3y minus 2. Factorise means putting it into brackets. Now for part C, we've got an equation. You could start by dividing both sides by 7. I'm personally going to expand that bracket just because I think it's good practice. 7 lots of f is 7f, and 7 lots of minus 5 is minus 35. So 7f minus 35 equals 28. Let's work backwards. Let's undo that. So I'm going to start by adding 35 to get rid of that minus 35. If I add 35 on the left to get rid of minus 35, I've also got to add 35 on the right, and that gives me 63. So I've now got 7f equals 63. If 7 lots of f, remember this is multiplying, 7 times f is 63, I can divide this side by 7 to just find out what f is, and also divide this side by 7, and that is 9. So f is 9 is your answer to that one. Question number 21. Show that 2 1/3 times 3 3/4 equals 8 3/4. So when I show that question, you don't want to use the answer. We're going to do this and show that we get the same answer from our working. Okay, so 2 1/3 times 3 3/4. Let's start by making both of those fractions top heavy. To do that, you're going to do the big number times the bottom number, add on the top. Big times bottom, add on the top. Okay, two holes and an extra third. Remember, each of those holes is 3/3. So you've got 2 lots of 3 and an extra 1. So big times bottom, add on the top. 2 times 3 is 6, add the 1 is 7/3. Times, and again here we're going to do big times bottom, add on the top. 3 times 4 is 12, add the 3 is 15/4. Now when we times fractions, we actually don't need to make the denominators the same. When you add and subtract fractions, you do need to make them the same. But when you're timesing, you do not need to make them the same. You can just multiply across. So 7 times 15, let's just do that over here. 15 times 7. Now 7 times 5 is 35. 7 times 1 is 7, add the 3 is 10. So 105 divided by 12. And then we just need to think, how many times does that go in? Just write out your 12 times table if you're not sure. 12, 24, 36, 48, 60, 72, 84, 96, and then it would be 108, which is too big. So 1, 2, 3, 4, 5, 6, 7, 8. So it goes in 8 whole times with 9 left over out of 12. I've got that 9 because I've gone from 96 up to 105 is an extra 9. Now we're almost there, but this fraction does simplify, and so this becomes 8 3/4 because both these numbers are in the 3 times table. So we can simplify it down. There we go. We've shown that we get the same answer that they do, and that is 3 marks. Question number 23. The diagram shows 4 triangles. 2 of these triangles are congruent. Now, congruent means the exact same shape and size. It might be rotated, reflected, but ultimately if you cut them both out, they would fit exactly on top of each other. So 2 of the triangles are congruent. Which 2? Which 2 of these triangles are exactly the same? Now, as a bit of a clue, if you look here, 10, the angle that it's opposite, remember angles in a triangle add up to 180. I've got 45 and I've got 55, which adds up to 100. So in this first triangle, the 10 is opposite the angle that's 80 degrees. So I need to find that where it happens again. In triangle C, 10 is opposite 55, so that's no good. In this one, 10 is opposite 45, so that's no good. And in triangle D, 10 is opposite 80. So it's going to be this one and this one that are the same. They are just turned round. So triangle A and triangle D are congruent. They are exactly the same triangles, just in a slightly different orientation. Question number 25. ADC is a triangle. AED, so that's this line here, is a straight line. And ABC is a straight line, that's that one there. EB is parallel to DC, we can see that from the little arrows. Angle EBC is 148, which is labelled on there for us. And angle ADC is 63. Work out the size of angle EAB. EAB is that one up there. If you go from E to A to B, the angle that is formed is that angle at the top. So that's what we're looking for. I'm going to pop an X there so we know that's what we're working out. You must give a reason for each stage you're working. Now, as an examiner, it's easiest for us to see the reason if you write it and you label the angles as you go. So the first one I'm going to say, I know that this angle is 63 degrees. Why do I know that? Well, looking at these parallel lines, I can make that F shape. And so that is corresponding angles are equal, is the rule that we're using there. So corresponding angles are equal. Perfect. And then this angle here, I know that this, if I do 180, take away 148. Now remember, more on the floor, borrow from next door. 10 take 8 is 2. 7 take 4 is 3. So this angle here is 32 degrees. What's the reason? Well, it's angles on a straight line add up to 180. And then last but not least, we can now look at that triangle at the top. So let's just highlight that for you guys. So that triangle here, we know that the angles in that triangle would need to add up to 180. So let's do 63 add 32. Which is 95, and then 180, take away 95, again, more on the floor, borrow from next door. 10 take 5 is 5, 7 take 9, I'm just going to borrow that one, 17 take 9 is 8. So there we go, x equals 85, and the final reason that I've used is because angles in a triangle add up to 180 degrees. Perfect. There we go. That is all of the reasons that I've used, and that would get me full marks, 5 marks for that one. So really well done if you got that. Question 27. The diagram shows a prism placed on a horizontal floor. The prism has a height of 3 and the volume is 18 meters cubed. Now, if you have a prism where you've got that cross section and then it goes back, that's what a prism does. You've got that same shape all the way through. To get the volume of that shape, it's the area of that cross section times by how far back it goes. So if they're telling me that the volume is 18, then I know that the area of that hexagon on the floor there, or at the top, however you want to look at it, the area of that must be 6 because they've multiplied it by how far back it goes or how long it is and got 18 meters cubed as their answer. So because they've times by 3, I know that the area of that cross section must be 6 meters squared. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force, and we're given the formula up here. Now, pressure is all about the area of the face that is in contact with the floor. Okay, it's about that face that is touching the floor. That is going to be the pressure forcing down. So pressure is force divided by area, and you might remember it as a formula triangle like this: pressure, force, area. We're working out the force in this case. So if I cover that up and do the sum that's left behind, we need to do pressure multiplied by area. So the pressure, we're told, is 75. And the area we've just worked out, just the area that is in contact with the floor, is 6. So 75 times by 6. Now we don't have a calculator, so we're going to need to do that. Let's just do it up here. 75 times 6. 6 times 5 is 30, so 0, carry the 3. And 6 times 7 is 42. Add the 3 is 45. So our answer for that one is 450 newtons. Always be really wary about the units for these questions. So the pressure was in newtons per metre squared, our area was in metres squared, and our force was in newtons. So everything matched up, and that's what we want to see. If it didn't, you might need to do some conversions to be able to get the right answer. Okay, question number 29. Given that A over B is 2 over 5 and B over C is 3 over 4, find the ratio A to B to C. Looks terrifying, but let's just write it differently. If A over B is 2 over 5, then the ratio A to B is 2 to 5. If B over C is 3 over 4, then the ratio B to C is 3 to 4. Now, if I want to combine these ratios and put them together, I really need the B's to be the same number. At the minute, I'm saying for every 2 of this, I've got 5 of these, and for every 3 of these, I've got 4 of these, which isn't very helpful when the B's are different. So I'm looking for a number that's in the 5 times table and the 3 times table, and that would be 15. You could go bigger, but you don't need to. Whatever you've done to this side, you need to do to the other side to keep this ratio equivalent. So I've times this by 3. I also want to times this by 3, and that's 6. With this ratio, I've multiplied that side by 5, so I also need to multiply this side by 5, and that is 20. And now that my B's are matching, I can say the ratio A to B to C is 6 to 15 to 20. And that's that one complete. I can't simplify it, not that they asked me to, but there we go. 6 to 15 to 20 would be your final answer. 43 marks on that paper, so we'll get a slightly shorter one of 37 next week. I hope you found it helpful. Let me know in the comments if you've got any questions about any of those at all, and I'd be happy to help you out more. Next week will be week 13. No, are we doing week 13? Next week will be week 14. Blimey, time flies. So yeah, week 14 next week. It'll be another non-calculator paper one, so I look forward to seeing you for that one. I hope you found it helpful. Let me know in the comments if you need any help.